Hello and welcome to the next edition of the HP Discover podcast series. I'm Dana Gardner, Principal Analyst at Inter Arbor Solutions, your host and moderator for this ongoing discussion on IT innovation and how it's making an impact on people's lives. Our next big data case study discussion explores how social gaming company Playtika uses big data analytics to deliver captivating user experiences and engagement. We'll learn how feedback from user action streams can be analyzed in bulk rapidly to improve the features and attractions of online games, and can help Playtika react well in an agile market. To learn more about leveraging big data in the social casino industry, we're pleased to welcome Jack Gudenkopf. He's Vice President of Big Data at Playtika in Santa Monica, California. Welcome, Jack.
Thank you. It's great to be here.
Tell us a little bit about Playtika. I understand that you are part of Caesars Interactive Entertainment and that you have a number of online games, but I don't know much more than that. What are you all about?
Yeah, so we have a few free-to-play social casino gaming. In fact, we're the industry leader. We have like maybe 10-ish games at this point. World Series of Poker you probably heard about. Slotomania, House of Fun, Bingo Blitz. Number of studios kind of combined. Worldwide, we're about 1,000 employees. As I say, I think we're the industry leader in this space at this moment now. And it's a very challenging space, as you might imagine, just with the in gaming itself. The amount of data, especially across all of these games, and collecting information about how the users play the game, and what do they like about the game. It's really a completely data-driven experience. You know, if we release a new feature and we get feedback, and of course it's a social gaming as well, and we find out that they don't like the feature, we have to rev the game pretty quick. It's not kind of like the old days where you go away for a year or so, you come out with something that you hope people like, Halo or something like that. It's more about the users driving the experience and what they enjoy. So while we'll try something with some content or something else and see if they like this feature functionality, if the data comes back immediately, as they do a slot spin and they have a new version of the game and then they're just clearly not playing, we literally change the game. In fact, in the Bingo Blitz game, we will rev the game as often as once a week, if you can imagine that. So we have to be pretty agile, and the data completely drives the user experience as well. And did they like this? And do they not like this? Should we make this game change? So it's a complete data-driven environment. That's what brought me there. I came from Twitter prior, where we used very big data, as you might imagine, with Vertica and Hadoop and such. But it's more about volume there, whereas it's about variety and velocity. And the changing of game events, and across all of our studios, you can imagine the amount of data that we have to crunch through and do analytics on it, and then get user feedback. The whole intention is to kind of get feedback sooner, so that we can change the game as rapidly as possible, so that they're happy with the game. So it's completely user driven as far as the kind of experience and what they enjoy, which is it's fun and makes it a challenge as well.
So being a data scientist in this particular organization gives you a pretty important place at the major table. You're not something they think about at the end of the month when we run some reports. This is essential and integral to the success of the company.
Yeah, that's a great question. Of course, we do analyze the data, for daily, monthly, and general KPIs, if you will, daily active users, monthly active users, those types of things. But you're absolutely right. With the game events themselves, we need to process the data as quickly as possible, do the analysis over the data. So analytics is a huge part of our processing. We actually have a game economy as well, which is kind of fascinating. And if you think of it in terms of like the U.S. economy, you can only have so much money in the economy without having inflation and deflation. And imagine if I won all the money and nobody else could have money to play with, it's kind of game over for us because they can't play the game anymore. So we have to manage that quite well. And of course, with the user experience and what they enjoy, and a free-to-play in particular, the demand is pretty high. It's kind of funny. that it's kind of like with apps that you pay for. The 99-cent apps are the ones that people think the most about. So when when somebody's spending $1, it's very important to them. So you want the experience to be a great experience for them. So the data-driven aspects of that and doing the analysis and analytics of it and feeding that back to the game is extremely important to us. And so the velocity and the variety of games and different features that we have and processing that as fast as possible is quite a challenge.
Now, a game like poker or slots or bingo, these are games that have been around for decades, if not hundreds of years, and they've had a new life online in the past 15 years, which is the dark ages of online gaming. What's new and different about games now, even though the game is essentially quite familiar to people? What's new and different about a social casino game?
Yeah, that's a great question. It's kind of funny. I've thought about that quite a bit. I think a lot of it has to do with the social aspect. Now you can play bingo not just with your friends at the local club. You can play with people around the world. You can share items and gifts, and if you're running low on money, maybe you can borrow some from your friends, and you can chat with them. So I think that just the whole social aspect just opened up all kinds of avenues. And I think in our case, with our games in the studios, because they are kind of familiar, I think they stand the test of time. Something like a bingo, like slots, as opposed to some new game that people don't really understand. They may like it, they may only like it for a while. I think it's kind of like playing Scrabble or Monopoly. With your family, it just is a game that is just very familiar and something you enjoy playing. But on the online and the social aspect of it, we can do things. I kind of explain it to other people. Imagine like Carmen Sandiego meets bingo. So we can have experiences where you're playing bingo and you go on this journey to Egypt and you're collecting items and you're exploring kind of Egypt and trying to get to another thing. So we can take it in places that you wouldn't normally take it, in a traditional kind of board game and in a more social aspect.
This really appeals to what's conceived of as entertainment in multiple ways for an individual. And again, as you established, the analysis and feedback loops are really important. All right, so I understand why doing great data analysis is so important to this particular use case. Now tell us a little bit about how you pull that off. What sort of data architecture do you have? Yeah. What sort of requirements do you have? What are the biggest problems you have to overcome to achieve your goals?
That's a great question. In fact, it kind of dovetails into one of the sessions that I did, actually. So if you think about the traditional way of consuming data and getting it into a reporting system, you have an extract. You're going to bring in data from somewhere. And of course, in our case, it's from mobile devices, it's from the web, it's from playing on Facebook. You have information about, how much money did you spend, and kind of user behavior, did they like it? So you extract that data as usual. And then you transform it, you reshape it, change it around a little bit to put it in a format to get it into a data warehouse like Vertica. Once you get it into Vertica, so you have the extract, the transform, and the load, the ETL, the traditional model. And you load it into Vertica, and then you're doing your analysis there where you can do SQL and joins and, do analytics over it. What we're doing actually, and kind of a new industry term that I'm kind of coining, is what we call a parallelized streaming transformation loader. So PSTL instead of ESTL, and I'll kind of explain that a bit. And this is about ingesting data as fast as possible and processing it and making analytics available through the entire data pipeline now instead of just in the data warehouse. So imagine instead of the extract, we're taking real-time data, streaming data. We're reading it, in our case, off of Kafka Q. Kafka is very robust and has been used by LinkedIn and Twitter, and so it's pretty substantial and scalable. We read the messages in parallel as it's streaming in from all the game studios, certain amounts of data here and there, from depending on the games, how much we do with that particular studio. With Bingo Blitz, in our case, we consume a lot more user behavior than, say, some of the other studios, but we ingest all the data. We need to get it in real-time streaming. So we read it in parallel. That's the parallel part, the streaming part, PS, parallel streaming. But then we take it from the streaming, instead of extracting, it's kind of being fed into us. Then we do parallel transformations in Spark and our Hadoop cluster. And think of it as just you're bringing in a bunch of JSON event data. We're putting it, think of it as like an in-memory table that's distributed and in Spark, and then we do parallel transformations, meaning we can restructure the data. We can do transforms from uppercase, lowercase, whatever we need to do, but it's done in parallel across the cluster as well. Where traditionally it was a single monolithic app that was running. Now it could run independent of, say, the extract or the load. But we have so much data that we need to also do the transformations in parallel. We do that in what are called RDDs, resilient distributed data sets. It's kind of a mouthful. But think of it as just a bunch of slices of data across a bunch of computers in your nodes, and then doing transforms on that in parallel. And then something that has kind of been a dream of mine is how do we get all that data in parallel at the same time into Vertica? Vertica does a great job of reading, doing MPP is what they call it, massive parallel processing. And all that means is just running the query and pulling data off of different nodes in the cluster. And then, maybe you're grouping by this and you're summing this and doing an average. But they hadn't really had anything to date. It was something that I tried to do when I was at Twitter, but managed to pull off now, which is to load the data in parallel. And what we do is while the data is in memory and Spark and distributed data sets, we use the Vertica hash function that will tell us exactly where the data will land when we write it to a Vertica node. So what we can do is say, user A, if I were to write this to Vertica, I know that it's going to go on this machine. User B will go to the next machine, and it just distributes the load. But we kind of a priori hash the data into buckets so that when we actually write the data, exactly that it goes to this node, and then Vertica doesn't have to move it, because usually you write it to one node and it says, no, you really belong over here, and so it has to move it and shuffle, kind of that shuffle from like a traditional map, but reduced. So we created something in conjunction with the Vertica developers. We announced it. That part of it is kind of there's a TCP server aspect that we extend in the copy command that exists in Vertica itself. So we literally go from streaming parallel reading into in-memory data structures, do the transformations, and then write it directly from memory into our Vertica data warehouse. What that allows us to do is get the data in as fast as possible from streaming right to the right. We don't have to hit disk along the way. And we can do analytics in Vertica sooner. We can also do analytics in the Hadoop cluster for older data and do machine learning, for instance, on that to do all kinds of things based on historical user behavior. And then we can actually push that further upstream in the streaming data to see, based on those machine learning, those models, how do we see the data coming in? If we're doing a sale or something like that, how well is it resonating compared to the past? And what we're doing is pushing the envelope to push the analytics as close as we can up to the actual game itself. So like we said, traditionally you do the analytics, get the feedback, change the game, release it in a week, et cetera. We're going to try to push that all the way up to be as near real time as we can. And basically this pipeline, the PSTL pipeline, allows us to do that and analytics and tighten that loop down so that we can get the user behavior to the user as fast as possible, actually.
Wow, it's intriguing. It sounds as if you're able to, with a common architecture, do multiple types of analysis readily, but without having to reshuffle the deck chairs each time. Is that fair?
That is exactly right. And that's kind of the beauty of this model and why I'm kind of putting out more prescriptive guidance around it, because you're absolutely right. It's kind of changes the paradigm of the traditional way of processing data. You're absolutely right. Once you have it in, as fast as you can and reshaping it while it's in memory, which of course is faster, and taking advantage of doing the parallel, transformations at the same time, and then the parallel loading as well, is just a way more optimized solution. We announced, for instance, some benchmarking last year at this conference. Facebook kind of stole the show, honestly, with like 36 terabytes an hour, 270 machines. With our model, you could do it with about 80 machines. So it scales very well. Some people say, well, you're not Twitter or Facebook scale, but the speed at which we want to consume the data and make it available for analytics is extremely important to us. The less busy the machines are, the more you can do with them. So, does it need to scale like that? No, we're not, processing as much data, but the volume or the velocity and variety is a big deal for us. So we do need to process the volume, and we do have a lot of events. I mean, the volume is not insignificant. We're talking about billions of events, mind you, but not on the sheer scale of say Twitter or Facebook. But the solution would work for both, both scenarios.
And so, Jack, with this capability of as analysis as close to real time, with the volume and the variety that you're able to accomplish, while this is a great opportunity for you to react in a gaming environment, you're also, I think, pushing the envelope on what analysis and reaction can happen to almost any human behavior at scale. Now, in this case, it happens to be gaming, but there's probably other applications for this. Have you thought about that, or are there other places you can take it within an interactive entertainment environment?
That's a great question. And yes, that's the answer. I can imagine all kinds of solutions for it. In fact, after my session, I had a number of people come up to me and say, we're doing like the Chicago Stock Exchange, and we have just massive amounts of streaming and data. This is a perfect solution for that. And I've had other people come in to talk to me about other aspects and other games as well that are not, social casino, that kind of genre. But they have the same problem. So it is the traditional problem of how do I ingest data, massage it, load it, and then have analytics through that entire process. It's applicable really in any scenario, and that's one of the reasons why I'm so excited about the PSTL model, because it just scales extremely well along the way.
Right. Well, let's relate this back to this particular application, which is highly entertaining games that react and maybe even start pushing the envelope into anticipating what people will want in a game.
Yeah.
What's the next step for making these types of games engaging? I'm even starting to toy with the concept of even artificial intelligence, where people wouldn't know that it's a game. They might even not know the difference between the game and other social participants. Are we getting anywhere close to that?
I think you're thinking extremely clearly on the spectrum. And analytics in general, before, like you say, it was kind of just general reporting and kind of the feedback loop. But you're absolutely right, and as you can see, it's kind of enabled through our model of prescriptive analytics. So looking at historical data, doing machine learning, we can make better determinations of games and game behavior that will drive the game based on historical knowledge or incoming data. That's more predictive analytics. And then, like you say, maybe even into the future of beyond predictive and prescriptive analytics, we can almost change as rapidly as possible, but we know sort of the user behavior kind of before the user knows the behavior. That would be a great world, and I'm sure we'd be extremely successful to get to that final spectrum. But just doing the prescriptive analytics alone, so that the user is happy with the game and we can get that back to them as quickly as possible. That's big in and of itself.
Maybe a new game someday will be Pass the Turing Test. You against our analysis capabilities.
Yeah, I mean that would be pretty cool. I don't know. Maybe maybe eventually it'll tie into the whole virtual reality, Oculus, and it'll be just the game is kind of happening based on the information and behaviors immediately. That would be kind of neat.
A very exciting world coming our way, right? We're only scratching the surface. Well, I guess I've run out of questions because my mind is reeling at some of these possibilities. One last area, though, for a platform like HP Vertica, what would you like to see them do intrinsic to the product? We have the announcement recently about the next version of Vertica, but what might be on your list, a wish list, if you will, for what should be in the product to allow this sort of thing to happen even more readily?
That's a great question. That's one of the reasons why we're actually here at the conference. It's one of the few conferences, honestly, that you can get to the actual developers, that you can actually get to the professional services and actually influence the product itself. One of the reasons why I like to kind of be on the leading edge or bleeding edge is so that we can affect the actual product development and what they're working on. And this is a great venue. I've been fortunate enough to be able to work with devs and people internal to Vertica for quite a while now. I just love the product, and I want to see it be successful. And I think the adoption and their more openness of like working with open source, like Spark and MapReduce, and because the whole ecosystem works well together, as opposed to opposing each other, which I think is what most people think. It's a very collaborative, cooperative kind of an environment, especially through our pipeline. I really like the fact that when I talk about things like Kafka and then parallelized streaming transformation loader and the PSTL, and that Spark is a core prominent part of our architecture, that now we're having conversations, and lots of them where we're here to help Vertica and influence them to invest more in Spark and the interaction between Vertica, Data Warehouse, and Spark and that ecosystem from Kafka, and funny enough, from the part of the work that we did with Vertica over the last year with reading streaming data from Kafka into Spark, of course, and then into Vertica, is they were like, hey, this whole reading real-time streaming data from Kafka directly into Vertica would be a great add-on, and they announced it here. Ben Van Diver and developers announced it. So I really want to be in a place, and this affords us to be in that place to influence where they're going, because it benefits all of us in the entire community. So being able to give them prescriptive guidance as well, and from the customer perspective, because this is what we're doing in the real world, of course, which is what they want to do, make us happy, we make them happy. Our investments in things like Kafka streaming and Spark, and how does Spark SQL work with Vertica and VSQL, and they don't necessarily have to compete. There's a world for both. So let's kind of coexist, and basically influencing that and having them be receptive to it is amazing, really. I mean, a lot of companies aren't very receptive to it, and taking the feedback from us as consumers and baking that into offerings. For instance, one of the things that in our model to load the data as fast as possible in parallel is that we pre-hash the data. So if you just take user IDs, for instance, and you kind of hash on those IDs so that you can put this user on this node and this one and this one and this one, kind of even distribution of data. That wasn't exposed in Vertica, and I've kind of been asking for it since the Twitter days for years. So we wrote our own version of it. I managed to have the Vertica developers, which is a rare and great opportunity, to review what we had done. And they said, yes, that's spot on. That's exactly the implementation. I said, it would be even better. I've been asking for this for years, and I know you have lots of other customers. Why don't you just make it available and for everybody to use, and then I don't have to use mine, and then everybody else can benefit from it as well. And they just announced that they're going to make it available. So being able to influence things like that I think just help the whole ecosystem is why we're here.
Well, excellent. I'm afraid we'll have to leave it there. We've been exploring how Playtika uses big data analytics to deliver captivating social game experiences and engagement for their end users. But we've also seen that they've got a tremendous amount of data science going on and an architectural approach to conquer some of these hurdles around volume, velocity, and variety that I think probably are applicable in many other cutting-edge applications. So a big thank you to our guest. We've been here with Jack Gudenkauf, Vice President of Big Data at Playtika, in Santa Monica, California. Thanks so much, Jack.
Thank you. It was a pleasure.
And a big thank you to our audience as well for joining us for this Big Data Innovation Case Study discussion. I'm Dana Gardner, Principal Analyst at Inter Arbor Solutions, your host for this ongoing series of HP-sponsored discussions. Thanks again for listening, and come back next time.